So the lesson on, what is it, the 29th? So in the list of videos, the lesson of the 29th, its objective, that's me talking about our lesson, its objective is going to be solve vector problems when given an angle between the vectors. When given an angle between the vectors. Okay, so every time we see an objective, we really don't even know what it means until we kind of work through the problem and look over it at the end. So it's just going to be a kind of another way to deal with vectors. And you're going to have some that are given in a weird way that you've never seen before. So up until now, we've seen winds and drawing and planes flying and this and that and the other. So let's just say we've got, let's just do this log fell down, a tree fell down, there's a log. And a couple people want to just put a rope around it and then start pulling. Well, this person is pulling at 70 newtons, and then there's someone over here that grabs the rope and pulls over here, and they're pulling at 90 newtons, not to scale. And let's see, angle between those is 82 degrees. So so let me refresh you about cell phone policy, right? During lecture, none, we'll lose it, right? After that is fine, okay? So so we want to know the force being acted on. What force is that log? What magnitude of the force is acting on that log, right? And its direction. So that means I've got to add together those vectors. So I need to know what the force that is. And you're not going to add 70 and 90. Please do not add 70 and 90, okay? That will not be an answer. I will not accept 160 on the quiz, right? You cannot just add the vectors together. That's just not how it happens, right? So here is the major tip for dealing with this sort of problem. So tip / trick, advice, whatever you want to call it. Choose one vector. Actually, let me give it in steps. All right, one. So choose one of the vectors. I always choose the strongest vector. So in this case, the 90 newtons is the strongest vector. So I'll pick that one, but you can. It doesn't matter what you do, but choose one of the vectors, and then step 2. Place that vector on the positive x-axis. Place that vector on the positive x-axis. So that's what us math people like to do. We like to take everything, doesn't matter what direction it's going, and we need some kind of uniform way to analyze it. So we place it right where we measure angles from. And then draw the remaining vectors. Having a hard time writing there. And I say vectors because there's always going to be, in this one, there's only 2 vectors, but there might be 3 or 4 of us pulling on it, right? So, all right, so we'll go and calculate it that way. So we've got the log. We're going to take the strongest one and put it on the x-axis, right? So let's go off of that screen and draw out what I'm talking about. So I've got an xy. We've only got one problem. We're almost done. So there we are. And I'm going to choose the first vector, which I said was 90 newtons, didn't I? Yep. Thank you. So let's do this one first because that work is easy. So just looking at that, I don't have to do any r cosine theta, r sine theta, because, well, let me backpedal one step. That vector has a horizontal and a vertical component. Most of the time, to find the x, we're going to do the r cosine theta and the r sine theta. But you and I don't need to do that because we can flat out see it. If it travels 90 units to the right and no units up, its x component must be 90 and its y component must be 0. Go ahead and test me by putting 0 and 0 in for sine and that respectively, and you'll see. Because we all know cosine of 0 is 1, so 90 times 1. And we also know sine of 0 is 0, so 0 times 90. Now, okay, so we slammed one of the vectors on the x-axis. Now the other, just draw the rest of the vectors. So I'm going to draw another vector. So let's go ahead and draw it in blue. So the next vector is 82 degrees away from that one. So it's not to be scale. I put it way up here. And I should have made that a bit shorter. There we go. And its length is 70 newtons. So just like the red vector, it also has an x and y component, a horizontal and a vertical component. So for me to be able to add them together, I need to know the x's of both vectors and the y's of both vectors. So I've got to go in and generate that. So let's see. I'm going to generate my x by doing r cosine theta and my y by r sine theta. So here we go. I'm going to type into my calculator. We're all going to do it together. I'm going to type in 70 times the cosine of this angle, and that angle is 82 degrees. And then I'm going to type in 70 times the sine of 82. So you're going to do the same thing, and don't forget to store your x and store your y. Actually, you won't. Actually, you probably don't need to do that yet, but yeah, just store it for right now. Just store it for right now. So I'm typing 70 cosine of 82. So I got 9.742, and I stored that as x. And I'm going to do the same thing for my sine. So 70 sine of 82. And I got 69.319. And I store it as y, which is alpha 1. It's looking like everyone's good. I'm giving a quick look around. You look okay? All right. Now, store. How do you get it to do what? Store. STO, which is the, you see it? So there are, yeah, you got it. There are video lessons yesterday. So we've got all those numbers in. So if you don't mind, I'm gonna get rid of those. We've got it stored. Now, that resultant vector, when I add those two together, this is not necessary, by the way. This is what I'm doing is not necessary, but it keeps everything together with what we've been doing. So if I were to model that vector and put it tip to tail, so did everyone just see me circle that? So I'll do it one more time. So if I were to move that vector and put it tip to tail on the end of the other one, so if I were to pick this vector up, I've got it in blue, and I were to put it like there and measure the resultant, it would be like that. And that document, that picture is very busy, so let me just redraw that over here. That is the vector we're analyzing. give or take a little bit. And it has a horizontal component and vertical component. So let's go and find that. So this vector right here in black has an X and a Y. So to find that, I'm going to have to add X1 to X2, and I'm going to have to add Y1 to Y2. So you and I are going to add, we're going to add 90 plus our X that we stored, and that would give us 99.74, because I erased it, so I had to pull it back up again. That makes sense though, right? 99.742. And then I'm going to add my 0 from my Y1 to my Y2. So I'm just going to pull up Y. And it was 69.319. So that right there is the component form of the vector. The question was to tell you what force is acting on the log. So the force is the magnitude of that vector. So I need to go find it. And that's the hypotenuse of a triangle. So I need to use Pythagoras' theorem. So let's go in all together. Let's all do the root of x squared plus y squared. Actually, we've got to store the new x. Don't forget to store that one as the new x. So, okay, did everyone hear me? You are storing 99.742 as the new x. And your y didn't change. So if the y did change, you would have had to store that as the new y. So now I'm square rooting x squared plus alpha 1, which is known as y squared. Hang on 1 second, I'll answer that. Let me just write this down. Okay, that is the magnitude of vector v, which is in newtons. Okay, what was the question? I added the two vectors together. So I added this x coordinate, which is 90, to this x coordinate, which was 9 point something, 9.742. So I added them together. So you always add the vectors. You always add the x's together and always add the y's together. And then that will give you the component form of the resultant. And then the magnitude of the resultant is found by taking the square root of the sum of the squares. Okay. Now I have to find direction. We're about 18 seconds away from being done. So we're going to do inverse tangent of y over x. So if you do that, I'll do that too. Inverse tangent of y divided by x. I got 34.799 degrees. 799, not 779. Okay. All right, let's just take a quick thing, because this is going to go in the, when I'm on my test, it'll go in my grade book. Looking at this picture, that's ultimately what you're doing. Is 34 degrees reasonable? Is my calculator lying to me? No, it's perfectly right. That's exactly what it should be. My x and my y are both positive. I am located in quadrant 1. All right, so that makes perfect sense. Okay, any questions for the good, which means help anyone out on a video? You got any questions? All right, I'm going to give you a worksheet, and we'll practice that, and then I'll talk again. I'll stop this video.